Okay, everybody. Today we'll talk about why polar bears are not really on the verge of extinction, and this will be polars plus pandas plus long list of many different data frame manipulation frameworks comparison. And for the sake of introduction, let's talk about myself, and this will give you some important context why we are here and why we are talking about this. And my name is Jakub Cierocki, and I will repeat it only once. My friend Jan Kantemilczek, and he's like one of the main inspirations for this presentation. While he was talking about pandas 2 years ago at PyData Bydgoszcz, he mentioned, it's like referencing to well-known stand-up rule, that you should repeat think twice to make people remember. Unfortunately, my name is not that fancy as Janek's one, so you will not remember it anyway. And let's progress to the main topic of our. I'm a senior machine learning engineer at DeepSense AI, and I specialize in predictive analytics. And that makes me work a lot with tabular data when the columns of the tables are typically not that complex data types like strings or timestamps. And of course, I love clean code, static typing, functional programming, and more important, I love polars. And I'm ex-R guy. Guess why? Because, until 2022, there was not really a great DataFrame library for Python, and this was one of the reasons I was stick to R for so long. Another reason was like my love for functional programming. And before polars, I used plenty of dplyr, data table, DataFrames.jl, Pandas, and PySpark. And some of those I really like, but at the same time, I not really like pandas. And for this presentation, except Janek, who already mentioned, I was also inspired by Patrick and by Michał, who also were pretty interested, and and I discussed this topic before. And this presentation will start with pandas, like why is it not really enough? We'll talk, but we'll primarily reference some external sources here. Then we'll discuss like more theoretically the paradigms, and then there will be just polars. And speaking more, like you should not expect here that we will like just discuss the most memetic and annoying pandas issues in detail here, but we'll rather focus on like the theoretical dispute about data manipulation paradigm, references to R and Julia, syntax comparisons, and of course benchmarks. And if you still want those pandas issues and like some pandas jokes, you really should watch Nienawidzę Pandasów, like in English, Why I Hate Pandas by Jan Kantemilczek at PyData Bydgoszcz 2022. And also that blog post of Apache Arrow, justified by 10 things I hate about pandas. It's pretty good. I highly recommend it. But before we start talking, so we don't want to talk too much about pandas here, but to make a reference point, we need to summarize some issues with pandas. And those issues are like, I really love pandas. AP design, like super inconsistent, way too many ways to do the same thing, and often falling back to the default Python. The data types and lack of data types before 2.0 version, there was like really timestamp, and everything else, it was either base Python object or NumPy, and NumPy data types are non-nullable. So this was like creating plenty of problems, and those strange conversions from NumPy float to Python object. Indexes, like in Pandas, is really built around indexes, and this is kind of it doesn't feel good like for me, and this adds additional complexity, and it's especially annoying when you're exporting files. And encouraging not really good coding practices is in Pandas, like this is the consequence of having so many ways to do the same thing, like falling back to the base Python very often. Like you commonly just you modify the column in place using list comprehension, or you just switch from piping next stages to in-place modification. This code is really barely readable. And actually, least important for me, performance. Like everybody is complaining on Pandas performance. It is pretty bad, but at least, especially 3.2, 2.0. But for me, it was not the main problem with Pandas. And we will talk. But the problems above are much more important for me, and there are solutions for those problems. And regarding now some theoretical part, like the data manipulation paradigms, because like really, you can group like the data frame libraries into two distinct groups, more like semi-distinct, and this will have a lot of implications in the later part of this presentation. And those groups, and this is my convention, this is my naming, but I call them like generally in-place imperative and high-level query engine. And in terms of the first one, This is typically the control flow is syntax defined. So it's like imperative paradigm. We often use that like square bracket syntax for matrix manipulation. Eager execution, like syntax is tightly bind to a single programming language. A lot of using indexes a lot, in-place modification, usually limited parallelism. And feels familiar? Yeah, it's Pandas. Pandas is very typical representative of this in-place imperative paradigm. But at the same time, there's a different paradigm, and everybody know at least query engine representing the second type, but this is still less common. And it's like this second paradigm is about declarative language. You write business logic, and really the framework is figuring out the control flow. Like those frameworks are typically out of core. They process the data out of core. Their language, the high-level API is language independent. You can quickly do bindings for another languages. You usually don't have indexes, and at least a single data frame column, immutable pointer, implementing copy and write mechanism. And of course, those libraries are typically non-natively powered. And in terms of the imperative paradigm, we already talked about Pandas. And of course, there are many other examples like those Pandas clones they are also like the R libraries, especially the R-based data table. This is like very typical example for this paradigm, and also kind of our data table and data face in Julia is also very typical with some exceptions, but not the typical except syntax-wise R deployer. And why is it not that typical? You can say because like the syntax, it looks like query engine, but under the hood, this is base data frame with some optimizations. And we talked about those two paradigms, and the Pandas is bad. So you really think why either the imperative syntax and eager executions are so bad? I don't think so. They are not. And we already know that Pandas is bad, as I said before. We know that imperative data manipulation is not necessarily bad. So the conclusion, some imperative data frameworks are pretty good. Especially, I would say DataFrames, JL, and data table. But you know what they have in common? They are not Python frameworks. They are frameworks for R, for Julia, and for R. And both Julia and for R, they implement their languages by design for scientific computing, for data manipulation. And Pandas is language for shell scripting. So if you want to make a Pythonic data frame manipulation framework, questionable idea. And Horan, I mentioned data table. Data table, it was like really like for so long, this was like a champion of data frame manipulation performance, like this R data table package, and it's natively powered. It supports like the lazy execution, but it's still very similar to Pandas in terms of how you manipulate the data. And in 2014, H2O made a comparison. Actually, they wanted to promote their own framework, their own Python clone of data table. And this showed that our data table is 84% faster in terms of the group aggregation than Pandas. And for 50 gigabytes, Pandas was not working at all because it doesn't support lazy execution. And like this early data table, this was indisputable king of data frame, like large data frame manipulation for so long. And now I would say it succeeded, but this was one of the reasons many people stick to R. And in terms of like the query engine examples, of course, traditional SQLs kind of, because there is some query optimization, but let's not talk about them. But we have Pandas, we have typically Apache Spark, and we have DuckDB. But we are not going to talk about DuckDB a lot, because DuckDB, it supports only SQL. Extended SQL, but still SQL. And both Pandas and Apache Spark, they support both SQL and some nice Python API. And let's talk about more of them. So why not Spark? Like, Spark is very popular, and Spark is like for this is like de facto standard for offline, for like not real time querying of this like huge data sets for this distributed query execution. So, and why not use it instead of Pandas? It's faster. It's like huge adoption already sold about it. It scales out really when you have like unlimited computational resources. You can scale out Apache Spark really nicely. So why not use it? I think you all know the answer. Like, it's pretty complicated to use it at the beginning, especially. Like the setup, install JDK, HDOP, Spark, environmental variables is pretty annoying. Like the Scala implementation, it's designed just for distributed computing, so it's not optimized for like a single machine workflows. And also Scala is just always slower unless you compile it with GalVM, then in C++ or Rust. And large execution plan compilation overhead is huge. I had a problems with this with at least two of my previous companies. Like, this was like a really big problem, and that's why I was kind of, theoretically transitioning the stages, the pipeline stages, to a different programming language, to theoretically much slower DataFrame library like deployer, just because this overhead. And this is the really Spark is overkill for single machines. We need something else. And now, finally, we're going to talk about Polars. And I think you were waiting for this, and I hope you will like it. And Polars, pretty fast start. 2020 first commit, 2022 like late in the year, pretty stable version. Like the 1.0 version just this month, really just this month, and written in Rust. You could guess it before. Apache Arrow data model, like Apache Arrow is now everywhere. Everybody loves it and everybody implements it, and it gives like a huge, even Pandas implemented it, and it gives like a huge boost for Polars. It's installable via pip, no complex setup like Spark, but this is like really not only a DataFrame library. This is like all up in process query engine. You can use it with SQL, in example, and you can see this GitHub stars plot. We have Polars running so fast. It's like only Spark, and only Spark and only Pandas are above, but Polars is catching up pretty quickly. And look here, they are like vargs and data table. There were another attempts to overrun the king, to overrun Pandas in a non-performant way, but they both failed, and they are both not maintained anymore. And benchmarks, everybody likes them. I hope so. I think so. Like Polars Pandas 1.2, so pre-Apache Arrow version. You see, goodbye and aggregation and join performance, like the huge boost. Like, this was like 84% less computational time, 5 GB data sets, and at the same time, on like 50 GB data set for join, the Pandas was not returning the result at all. So, like, really huge boost. And now, 2024, Pandas was trying to catch up with by implementing Apache Arrow, but they didn't really. It didn't really work well. Like, it's much faster, especially like here for goodbye aggregations, but for join is almost as bad. And this is not really a huge big deal. And the TPECH benchmark, like very common, like standardized benchmark, and here this is like the implementation by Polars developers, and you see, even without the data loading, where data loading, this is a stage when Polar benefits so much. It takes an edge over other libraries, the data loading, and even without data loading, look how Polars is fast. And DuckDB is also very fast, but it's just SQL. And more benchmarks, check the CPCH by Dask developers benchmark, and also the DataCamp benchmark, but this one is like really strongly biased against Polars. So I'm not like, they just use very simple queries without pipelining in eager mode. So this is like the benchmark which does not promote Polars at all. And some of those benchmarks actually as well, because they are just single operation benchmark. And Polars really has an edge when you pipeline multiple operations in a lazy mode and just collect everything at the end. EO, another big advantage of Polars. We can, not only like CSV files, JSON files, but we can query relational databases. We can query Excel files. We can query like the complex modern data formats like Apache Parquet, Apache Avro. And because we can query Apache Parquet, we can also query Apache Iceberg, Delta Lake, and Hive. But Polars supports not only querying the files, because all those data lake houses, data lake housing technologies, they rely on Parquet files or other files. But Polars supports not only that base Parquet, but Polars can natively make use of the metadata stored by each of those data lake housing platforms. And this is very convenient for kind of smallish big data workflows that like the data is big enough that you really want to have like a distributed data lakehouse, like Apache Iceberg. But on the other hand, you don't need that speed that like, like the single machine, like powerful workstation, Polars on one, like a powerful workstation is enough. You run it out of core mode, and it can really like process like 100 gigabytes data set. Built-in data types. Python with Polars, PyPolars supports like many, because thanks to Rust, thanks to Apache Arrow, supports many the data types, and those data types are very convenient. You have like also like the nested complex data types. You have like the categoricals. You have plenty of temporal data types, and you know what? They are all nullable. There's no longer that problem with Pandas 1.2 that like like it fallbacks to object when you want to make an integer or boolean with a missing value. And laziness, we talked about this, out of core execution, like the query optimization, but how it works into the code, like it started, with our data table. There was first in like this was before implemented there, but Polars supports it as well. But it's not only like the batch processing, but it's also like the query execution and zero copy file access. It is for Fargate files, and the syntax goes like this. So you can just, in terms of read in the prefix of the module method, you just have scan, or you just turn existing data frame using lazy, and at the end, after many operations are added, you call connect. And it runs the query execution plan, it returns the batch processing mode if the data is too large. Syntax comparison. Like we are gonna compare primarily to Pandas here and later PySpark, and you can have a look. Polars, like in terms of like the operations like joins, concats, and pivots, like the syntax is very similar. It's almost the same. Like sometimes like you like the main difference is like you more often call like from the data frame itself, not from the package. But it's like very similar syntax. But if we go for filter, group by, and column manipulation syntax, you see it starts becoming very different. Like Pandas, really, it relies on indexes, it relies on square brackets, and in-place modification is very different. While Polars code is longer, but it's very readable and it's more consistent when you pipeline multiple operations. When you pipeline pivots, group binds, joins with like those column, it's very consistent. It's very one stage after another. And with Pandas, it's you just jump. You write two different codes, one after another. But what about PySpark? Here it's different. And now let's take exactly those 4 examples of Polars and compare them to PySpark. And you can see it's almost the same. Just replace PL with F, with large F, or any other alias. Just replace snake case with camel case, and you get the same code, almost the same code. Like the regex function is different. And that's like that's the thing. Like the Polars syntax is really inspired by the PySpark syntax, and they are very similar. And that for people who are very experienced with PySpark, like Polars will be much easier. And also PySpark just follow the same properties, like it's like lazy, like the query execution laziness, everything. So some drawbacks, of course, like no library is perfect, and Polars has some drawbacks as well. But I really feel like, and some of them, they are inevitable consequences of the design. But there's one main exception, like some operation does not support lazy execution, like I think pivot, and this is really annoying. And this really, I hope this is gonna be fixed later on the track. Either with a workaround or like some serious implementation. I kind of understand why, because like the pivots, they really like totally reshape the columnar structure, and you need to totally copy all the memory anyway. So I kind of understand why it does not support laziness, but this is just inconvenient to use. But except this, you have like just typical like that's less important thing, like lower adoption, quickly changing, a little bit more boilerplate, limited Rust in Python is not a problem, not very Pythoning. I don't care personally. And to summarize, because there need to be finally a summary, we're very close to the end. Polars, very young, did this month, stable 1.0 version, DataFrame library query engine. Declarative syntax, so kind of like SQL, but in Python, like kind of SQL, like or even more like PySpark, because it's in Python. It's very fast. Natively parallel query execution, out of core, zero copy, and this is zero copy both ways. You can load Parquet files, you can exchange, you can, in example, convert to PyArrow data format in a zero copy manner. Written in Rust, thanks to Rust, is so fast. And it supports not only Python via pip, but it supports also R and Node.js. Who would use Node.js? Regarding, of course, Apache Arrow memory representation that allows for the zero copy approach, and this is like this is like really an industry standard for analytical data formats. All the types are nullable, and rich IO. Calling those all the databases big data lakehouses. It's very nice when you don't need a separate tool for this. And this all, in my opinion, makes it really a great library. And you should really give it a chance. And you should really not disqualify it at the beginning because it's so different. Because it's big, like those small examples, they haven't really shown like how much different Polars is in terms of API design, but it's very different. And this is different philosophy, and this different API design is a consequence of implementing different paradigm. And many people, I have many friends who are like great data scientists, but then they were kind of using a lot of Pandas, but not that much PySpark before, and they really, even they see the disadvantages of Pandas, they kind of struggle to transition to Polars because the API feels strange. And they really, at the beginning, sometimes you can feel like this different paradigm makes a bad API. And you should really give a chance. If you get used to the declarative programming paradigm, you will understand why this API is great. And some use cases, because Polars is great, but it's not for every use case. And if you don't need to do a lot of wrangling with data frames, if you know Pandas, if you know Pandas, and if the other libraries like Darts they support only Pandas, stick to Pandas. It's fine. Like small amount of code, no problem to no point to put additional dependency. Like if the data set is huge and like more hundreds of gigabytes, and you have an access to like very scalable like cloud or like a powerful data cluster or scalable like cloud computing platform, when you can really like scale the jobs like very easily, consider using Spark or Dask. This will be those technologies scale up, and this is like really sky is the limit. And for Polars, this is because of out of core, it's not gonna break, not return the result. But when you go into hundreds of gigabytes, it starts to become slow. And otherwise, I would say always go for Polars. This should be like a default choice for data frame wrangling in data science, machine learning engineering, in data engineering. Small, medium, big, smallish, big data. All those kind size of data set fit Polars. Many other libraries, like Nixtla libraries, they already start to support Polars. And that's why I highly recommend it to go when in a new project to just start from Polars. And that's it. Thank you very much. Thank you. I hope you enjoyed it. I hope you like it.